Beneath the surface of the ocean, where sunlight fades into blue silence, a shadow moves with effortless control. It glides without hurry, without wasted motion, shaped by a history older than forests, older than dinosaurs, and older than most life forms we recognize today. For hundreds of years, sharks have survived in Earth's oceans. They have endured mass extinctions, changing climates, shifting continents, and the rise and fall of countless marine animals. But sharks are often misunderstood. To many people, the word shark brings to mind only one image: a great white, jaws open, charging through the water. But the real world of sharks is far richer than that. Sharks are not just one kind of animal. They are a vast and diverse group of fishes with different shapes, diets, behaviors, and lifestyles. Some sharks are powerful hunters. Some are slow-moving scavengers. Some hide on the seafloor like living carpets. Some glow in the darkness of the deep sea. Some are small enough to fit in your hand, while others are the largest fish on the planet. Today, scientists recognize more than 500 species of sharks. They live in nearly every marine environment, from tropical coral reefs to cold polar waters, from muddy river mouths to the open ocean, and from sunlit shallows to the black depths of the abyss. The largest shark alive today is the whale shark. This gentle giant can reach around 12 meters in length on average, with some individuals growing even larger. Despite its size, it feeds mainly on plankton, fish eggs, and tiny marine animals filtered from the water. On the opposite end is the dwarf lantern shark, a deep-sea species only about 15 to 20 centimeters long. It is so small that an adult could rest comfortably in a human hand. Yet despite their differences, all sharks share several defining features. First, sharks have skeletons made of cartilage rather than bone. Cartilage is the same flexible material found in our ears and noses. It is lighter than bone, which helps sharks stay buoyant and move efficiently through the water. Sharks also have multiple gill slits on each side of the head, usually 5. Some more primitive species, such as cow sharks and frilled sharks, have 6 or 7 gill slits, a feature that connects them to very ancient shark lineages. Their skin is covered with tiny tooth-like scales called dermal denticles. These denticles make shark skin feel smooth in one direction and rough like sandpaper in the other. But they are not just for protection. They also reduce drag, helping water flow smoothly over the shark's body. In a way, a shark wears a living suit of hydrodynamic armor. Sharks also possess sensory abilities that seem almost supernatural. They can smell faint chemical traces in the water, detect low-frequency vibrations, sense movement through pressure changes, and even pick up the weak electrical fields produced by other animals. This gives them an extraordinary awareness of their surroundings, even in darkness, murky water, or deep ocean environments. Modern sharks are classified into several major groups. Ground sharks are the largest order and include many familiar species, such as tiger sharks, bull sharks, reef sharks, cat sharks, and hammerheads. These sharks often have streamlined bodies, wide mouths, and protective eyelids called nictitating membranes. Mackerel sharks include some of the most famous open ocean species: great whites, makos, threshers, basking sharks, goblin sharks, and megamouth sharks. Many are built for speed, strength, or unusual feeding strategies. Great whites and makos are powerful hunters, while basking sharks and megamouth sharks are filter feeders. Carpet sharks include nurse sharks, bamboo sharks, wobbegongs, and whale sharks. Many have patterned skin and live close to reefs or the seafloor. Wobbegongs are masters of camouflage, lying motionless until prey comes close enough to swallow in a sudden strike. Bullhead sharks, also called horn sharks, are smaller sharks with blunt heads, fin spines, and teeth suited for crushing shells. Angel sharks look more like rays than typical sharks, with flattened bodies that allow them to bury themselves in sand and ambush passing prey. Saw sharks have long snouts lined with teeth, which they use to slash at fish or disturb animals hiding in sediment. Dogfish sharks and lantern sharks include many deep-sea species. Some lantern sharks are bioluminescent, producing their own light in the darkness. Cow sharks and frilled sharks look especially ancient, with extra gill slits and primitive body features. The frilled shark, with its eel-like body and strange gill frills, almost seems like a creature from another age. This diversity shows that sharks are not simply ocean predators. They are an entire world of evolutionary designs. To understand why sharks are so successful, we need to look at their anatomy. Their cartilaginous skeleton gives them flexibility and reduces body weight. Because sharks do not have the gas-filled swim bladder found in many bony fish, they rely on other adaptations for buoyancy. Their cartilage is light, their pectoral fins generate lift like underwater wings, and their large, oily liver acts almost like a natural flotation system. In some sharks, the liver can make up a significant portion of the body's weight. Most sharks have streamlined, torpedo-shaped bodies. This helps them move through water with minimal resistance. Their tails vary depending on lifestyle. Fast hunters like Marcos have strong, crescent-shaped tails for bursts of speed. Great whites use powerful tails to launch themselves upward during ambush attacks. Thresher sharks have extraordinarily long upper tail lobes, which they use like whips to stun schooling fish. The jaws and teeth of sharks are among their most famous features. Unlike humans, sharks do not rely on one permanent set of teeth. Their teeth are constantly replaced. When a front tooth breaks, wears down, or falls out, another tooth moves forward from behind, almost like a conveyor belt. Some sharks may lose and replace thousands of teeth over a lifetime. Tooth shape reveals diet. Great whites and tiger sharks have broad, serrated teeth for cutting flesh. Makos and sand tiger sharks have long, pointed teeth for gripping slippery fish. Nurse sharks and horn sharks have flatter teeth for crushing hard-shelled prey like crabs, snails, and sea urchins. Filter-feeding sharks, such as whale sharks and basking sharks, have tiny teeth that are not important for feeding. Sharks breathe by passing water over their gills. Some sharks must keep swimming to maintain water flow over the gills, a process called ram ventilation. This is common in active species like great whites and makos. Other sharks, such as nurse sharks and wobbegongs, can pump water over their gills while resting on the seafloor. This means not all sharks die if they stop swimming. Some can rest perfectly well. Their senses are even more remarkable. Shark vision is often well adapted to low light. Many species have a reflective layer behind the retina called the tapetum lucidum, which improves vision in dim environments. Their eyes may glow when light shines on them, much like the eyes of cats at night. Some sharks also have protective eyelids, while others roll their eyes back during a bite. Their sense of smell is legendary. Sharks can detect tiny amounts of blood, oils, or amino acids in the water. More importantly, they can track the direction of a scent plume by comparing signals from each nostril. This allows them to follow chemical trails through the water toward injured prey, spawning fish or carrion. Sharks also hear low-frequency sounds, especially the irregular vibrations made by struggling animals. Sound travels far in water, so hearing helps sharks detect activity from a distance. The lateral line system acts like a sense of touch at a distance. It runs along the shark's body and detects pressure changes, water movement, and vibrations. Even in darkness, a shark can sense the motion of nearby fish through the water they disturb. Then there is electroreception. Around the shark's head are tiny jelly-filled pores called the ampullae of Lorenzini. These organs detect weak electrical fields produced by living animals. Every heartbeat, muscle movement, and gill motion creates a tiny electrical signal. A shark can use this ability to find prey hidden beneath sand, such as rays or flatfish. Hammerheads, with their wide heads, may sweep the seafloor like metal detectors, searching for buried prey. These sensory systems work together. A shark may first hear a struggling fish, then follow its scent, feel its movement through the lateral line, see it in dim light, and finally aim its bite using electroreception. This layered hunting system is one reason sharks are so effective. Shark reproduction is just as fascinating. Unlike many fish that release eggs and sperm into the water, sharks reproduce through internal fertilization. Male sharks use paired organs called claspers to transfer sperm to the female. After fertilization, shark embryos develop in several different ways. Some sharks are egg layers, or oviparous. These species produce tough egg cases often called mermaid's purses. The egg case protects the embryo as it develops using yolk for nourishment. After weeks or months, a fully formed baby shark hatches. Cat sharks, bamboo sharks, and horn sharks are examples of egg-laying sharks. Other sharks are viviparous, meaning they give birth to live young nourished through a placenta-like connection. In these species, the developing embryos receive nutrients from the mother in a way that is surprisingly similar to mammalian pregnancy. Many requiem sharks, including bull sharks, lemon sharks, and some hammerheads, reproduce this way. A third method is called ovoviviparity, or aplacental live birth. In this system, eggs develop and hatch inside the mother, but there is no placenta. The embryos rely on yolk and, in some species, unfertilized eggs provided by the mother. In more extreme cases, embryos may even eat their siblings before birth. Sand tiger sharks are famous for this. Many embryos may begin developing, but usually only one survives in each uterus, meaning the pups that are born have already survived competition before entering the ocean. Some sharks, in rare cases, can reproduce without males through parthenogenesis. This has been documented in species like zebra sharks and hammerheads, especially when females are isolated from males. It is not their normal method of reproduction, but it shows how flexible shark biology can be. Most sharks follow a slow life history strategy. They grow slowly, mature late, and produce relatively few offspring. A shark litter may contain only a few pups, and some females do not reproduce every year. Gestation can last many months, and in species like spiny dogfish, pregnancy may last close to 2 years. This means shark populations cannot quickly recover when too many adults are killed. Once born or hatched, baby sharks receive no parental care. They are miniature predators from the start, equipped with teeth, senses, and survival instincts. Many species give birth in nursery areas such as mangroves, shallow bays, lagoons, or estuaries. These habitats provide food and protection from larger predators. Lemon shark pups, for example, may spend years in mangrove nurseries before moving into deeper reefs. Feeding behavior among sharks is highly varied. Great white sharks are famous ambush predators. When hunting seals, they often attack from below, using surprise and speed. A great white may accelerate upwards so powerfully that it breaches completely out of the water. This dramatic behavior is most famous in places where seals gather near deep water. Tiger sharks hunt differently. They are broad opportunists, eating fish, rays, turtles, seabirds, crustaceans, carrion, and even human-made debris. Their strong jaws and serrated teeth allow them to cut through tough prey, including turtle shells. Shortfin makos are built for pursuit. They chase fast fish like tuna and mackerel in open water. Their streamlined bodies, strong tails, and partial warm-bloodedness help them perform in cooler waters and burst forward at impressive speeds. Hammerheads specialize in detecting prey on the seafloor. Their wide heads are packed with sensory organs and help them locate buried stingrays. A great hammerhead may pin a ray down with its head before biting into it. Thresher sharks use their tails as weapons. They swing the long upper lobe like a whip into schools of fish, stunning or injuring multiple prey at once. Saw sharks use their toothed snouts to slash at fish or stir up hidden animals in the sediment. Other sharks rely on stealth. Wobbegongs lie camouflaged on the seafloor, blending with rocks and coral. When a fish comes close, they open their mouths suddenly and suck the prey in. Angel sharks bury themselves in sand and strike upward in a sudden burst. One of the strangest feeders is the cookie-cutter shark. This small deep-sea shark attaches to larger animals using suction-like lips, then twists its body to carve out a round plug of flesh. Whales, dolphins, large fish, and even submarines have been found with cookie-cutter-shaped marks. And then there are the gentle giants. Whale sharks, basking sharks, and megamouth sharks feed by filtering tiny animals from the water. Whale sharks may actively suck in plankton-rich water, while basking sharks cruise slowly with their enormous mouths open. These sharks prove that not all sharks are tooth-driven hunters. Some survive by harvesting the ocean's smallest life forms. Sharks also have complex movement patterns. Some are homebodies, staying around the same reef, bay, or coastal area for years. Nurse sharks may return to familiar resting places. Reef sharks may patrol the same reef system regularly. Others are long-distance travelers. Great white sharks have been tracked moving between California and Hawaii. Whale sharks migrate to seasonal feeding areas where plankton or fish eggs are abundant. Blue sharks and makos can cross wide stretches of ocean. Tiger sharks may roam between islands, reefs, and open waters. Many sharks also move vertically through the water column. Some stay deep during the day and rise at night to feed. Others dive into cold, dark water to hunt squid and then return to warmer surface layers. These daily vertical movements help sharks follow prey and conserve energy. Sharks grow and age slowly. Small coastal species may live for 15 to 20 years, while larger species can live for decades. Great whites may live over 70 years. Whale sharks may live for many decades. Greenland sharks are the most extreme example. Living in cold Arctic and North Atlantic waters, they may survive for hundreds of years, making them the longest-lived vertebrates known. This slow growth and long life are part of what makes sharks vulnerable. When adult sharks are removed faster than they can reproduce, populations decline quickly and recover slowly. Ecologically, sharks are vital. Many sharks are apex predators, sitting at or near the top of the food web. By feeding on weak, sick, or injured animals, they help keep prey populations healthy. They also prevent certain species from becoming too abundant and disrupting the balance of an ecosystem. When sharks disappear, the effects can ripple through the food web. Without large sharks, mid-level predators may increase. These predators may then consume too many herbivorous fish. With fewer herbivores, algae can grow unchecked and smother coral reefs. In another example, fewer sharks can allow ray populations to increase, which may put heavy pressure on shellfish beds. Sharks also shape behavior. In places where tiger sharks are present, sea turtles may graze more cautiously and avoid overusing certain seagrass areas. This helps protect the seagrass habitat, which supports many other species. Even the fear of sharks can help maintain balance. As scavengers, sharks recycle nutrients by feeding on dead whales, fish, and other large animals. By moving between habitats, they also help transport nutrients across the ocean. A shark that feeds in one place and releases waste in another becomes part of the ocean's nutrient circulation. Sharks are not invincible. Young sharks may be eaten by larger sharks. Even adult great whites can be hunted by orcas. But in many marine systems, sharks are among the key animals holding the food web together. Sharks are not monsters. They are ancient survivors, finely adapted predators, filter feeders, navigators, scavengers, and guardians of balance. Their bodies are shaped by millions of years of ocean life, cartilage and muscle, rough skin and replaceable teeth, powerful senses and silent movement. From the great white launching upward beneath a seal, to the whale shark gently filtering plankton, to the lantern shark glowing in the deep, each shark tells a different chapter of the ocean's story. They patrol reefs, cross open seas, hide in darkness, and move through waters we have barely explored. They remind us that the ocean is not empty space. It is a living system of relationships, and sharks are one of its oldest and most important threads. So the next time you look out across the water, Imagine what moves below, the quiet silhouettes, the ancient instincts, the unseen migrations, and the predators that help keep the sea in balance. For hundreds of years, sharks have mastered the ocean depths, and today they remain among the most extraordinary animals on Earth.